So there's that. now I have a PVA with exposed to glutathione for 72 hours. So this sample, I'm going to soak it for about an hour to see if the fiber does not dissolve in water. And if it does not dissolve in water, then we can try to grow neurons on it. This instrument is the Fourier transformed Fourier spectrometer, and it shows the resultant of the absorbent in Fourier light that shows the combination of constructive and destructive light in the sample that shows the different wavelengths. And in the infrared spectra, we have a graph that shows the result of the PVA with glutathione. So each peak tells me what element is on it, and it can also tell me if the sample has been contaminated or not. So right here I can see a big broad peak, which tells me that it's probably an alcohol group, which is good because PVA is made with partially alcohol, and all the rest of the peaks are showing like the elements of that glutathione or the PVA.
combustion and aspirating out the stuff. Is it good?
Yeah.
So based on the result, the heat treated fiber EVA with 2% acetic acid has been a success because there's neurons that grow on that. So, and then the reason why we do it heat treated because that it does not dissolve in water. EVA is really soluble in water, so it's a good thing that we see that it's not dissolved in water and it's growing on that. So it's like one step forward to helping people with neuron problem. For glutathione, we thought that we have high expectations because we thought that when it exposed, it would not dissolve in water. Because there are causes of heat treatment, it did not crystallize that much as the glutathione, but for some reason it does not work. But focus on the good news. Neurons grow on heat-treated fiber.